Welcome to the Additive Report Advisor, a webcast series intended for fabrication and machine shops on the topic of additive manufacturing. Our guest today is Michael Celardo, or Mike, who's with Cumberland Additive. He serves as Vice President of Engineering and Business Development. Let's shift gears, going even a level deeper, more into day to day operational kind of considerations. A couple things that you said have really caught my attention. Uh, First one was you can't insource it all. So you're saying Cumberland Additive been at it since what, 2006, under various names. Uh, you don't intend to try to do it all. So is that an attitude that a job shop looking to get into additive manufacturing should also build upon? You know, do what you think can become a core competency, but also rely on others to source elements of that workflow.
Yeah, I think a business theoretically could insource everything and be very successful, but you'd have to have a ton of capital because there's tons of equipment, and you'd have to be willing to take on the burden of all the accreditations that you have to carry to do all those ancillary activities. And that could be NADCAP for heat treat. It could be ISO 17001 for a certified inspection lab. It can be mechanical testing, whatever it may be. And so having to take on that extra overhead and administrative burden can bring the operational side of the business down. So you have to kind of pick and choose what you go after. And if you have friends in the industry, if you already have the network effects, then leverage your friends in heat treating and machining and testing, whatever it may be.
What about outsourcing metal additive work? You know, in the old days of the service bureau model, that when I used to be in it firsthand, you did what you could with your available capacity, but you had friends in the business where you turned to them and say, "Hey, got some work. I can't handle it." Is that something that happens in the metal additive space? And is it something that job shops should learn to become comfortable with?
Definitely. So even for us, I mean, you've heard all the machines that we have, both metals and plastics. There are still some things that we outsource. Um, and so that's just a byproduct of us not having a core competency in that manufacturing process. So we're not shy about it. Our customers know we're outsourcing it, but because our customers have such a good reputation with us, they're okay with us being sort of a middleman in that approach.
The other thing you said was early engagement with customers. And in your bio, we had the statement there that you help to transition components to additive manufacturing. Can you combine those two elements to explain, to give job shops an understanding of what it could take to bring in a live additive project?
Sure. So because we have good relationship with customers, what we try to push is a collaboration on the front end in engineering and design for additive. Not every part is a good candidate to just transfer one to one. You may be looking to transfer a casting to additive. Can it be done? Yes, but in every case, is it financially beneficial? Maybe not. So you have to have the know-how to be able to communicate to your customer whether or not it is a good decision. And then if there's candidates of parts that are good potentials, then there's always a back and forth on what that looks like. Yeah, so that would be the suggestion there, is to try to engage customers early and convince them that you offer something extra that they can't do on their side, and then engage in that collaboration over time to develop the parts further.
Excellent. One other thing you said that I don't want to I want to really drive home. You mentioned that some of your legacy machines, faster material swaps. So eh, I'm gonna frame this. You know, a lot of people talk about a limitation of laser-based powder bed fusion, metal additive manufacturing is a limited set of alloys from which to choose. Now, what I want to point out is even if you had every alloy under the sun, it may not be practical for a job shop to consider running those because what did you say on the best on the easiest to convert? What did you say? 4 to 8 hours? Is that what you said to do a material swap?
Yeah, so for us, we've developed a set of procedures that our technicians follow step by step to ensure that we don't miss something. Because worst case scenario, you're converting between two materials, you don't clean out a certain orifice or seal, and you get contamination of the other material. And then everything that you've produced on that machine after that inflection point in time is questionable. So you have to have a protocol in place. So for us at best, that's a day for a conversion. And so if you're running small volumes and high mix, then you're going to have a heck of a time flip-flopping back between materials. So definitely a consideration when selecting machines.
What's your usual MO? Does the majority of your machines stick to one material and you only change if absolutely forced to, or do you use a model where each machine is open to being converted to another material, job to job, project to project?
Company policy-wise, just our general framework for how we allocate materials to machine is open. So we don't mind which materials on which machine. However, we cater to the customers in a lot of cases. So there's a lot of customers that don't want that change out because of the potential for contamination. So as a byproduct, we have over time consistently had machines dedicated to individual materials and not converted them over. Pretty much every machine here at some point has been converted over at least once, but that's over many, many years. And that was a permanent conversion from one to the other, not a change out week over week.
Yeah, I guess the bottom line message is don't have a plan of you're going to swap materials between jobs routinely because that's going to eat you alive. You're going to have a huge opportunity cost on that because of that downtime to swap out the material. And you also mentioned that some of your customers won't even allow you to do that. Specifically like aerospace, that has to be pick the material, a titanium, a cobalt chrome machine. Don't you dare put anything else in there because just the possibility of contamination ruins our ability to certify. So, uh, yeah, what I'm hearing you say, Mike, is for a job shop just getting started, pick that customer, but back to understand the needs. And it may be very wise to pick a material and have the expertise and build the business out on that material. And after that, then and only then consider adding other materials to your portfolio. Make
Exactly.
sense?
And the other maybe slight change to that would be if you can't just pick one, maybe pick material families so that the chemistry composition of those materials is very close. So if there were to be some issue with clean out or changeover, you're not converting from nickel 718 to titanium and then say, oh no, we didn't clean it out. Well, that's a huge implication. But if you're going from two different flavors of stainless steel, less of a consideration because most of the underlying elements are essentially the same.
Okay, excellent. I'm going to round out with a couple of questions here. If we can be real brief on this. So I want people to understand too, there is the opportunity to use vendor supplied parameter sets for a specific material on run of the mill parts without any additional process development. But you and I were talking as we go from simple to complex in terms of geometry or requirements, uh, the demands to make that happen can grow exponentially. You still agree with that statement, or what flavor, what color commentary can you add to that to set expectations properly for job shops?
Just considering the machine OEM parameters or anything
Uh,
else.
Anything else, whatever, you take the conversation where you think it needs to go to help the job shop.
Sure, yeah. So let's say I was a job shop, I just got set up. I went through all the rigor of selecting industry, customer, material, machine. I've got my machine, I'm ready to go. The machine OEM provides a parameter set for the material I'm going to run. They maybe help me start off with the first test prints, and I get an output of that material. Well, now I need to do some testing. So that can be dimensional testing. For sure, there's going to be some mechanical testing, might be non-destructive testing. And then all those are going to give me feedback to know how well I did on the initial print. So herein lies maybe the next pitfall is what happens if the results I get from those tests aren't what I was hoping to get initially? Does my company, do I have the expertise to analyze it and figure out the solution? So the parameter set that the OEMs give you are probably going to work in most cases, but in some cases, the geometry of the part will change the effectiveness of all the inputs you've given. Now you have to know how to tweak that. And so that's where having a background in additives definitely helps, or having perhaps another company that you're interfacing with or partner with or contracting to help with engineering services in additive can get you past that hurdle. Help look through the data and figure out, oh, if we change some things in the parameter here, we change the orientation in the build, change support structure, whatever it may be.
Excellent, excellent. Last question in the day to day, and then we're going to wrap up with a big broad question. Uh, we already know the answer to this. So you're running your first gen metal additive machines that you guys acquired and using those productively. Uh, I want to get across the point that so many people fear obsolescence because additive manufacturing has this perception of changing day over day, week over week, month over month, and everything's just screaming ahead. I don't believe that to be true. Most of it is incremental advancements. But is there any comforting thoughts you have in that you're running machines from the 2006 era productively with regards to making a decision today under the fear of it becoming obsolete?
Well, I think it's absolutely a consideration no matter what. And every accounting model will tell you, especially maybe for additive machines specifically, will have a faster depreciation cycle than some other capital equipment. Just because there's always new models coming out, the technology is rapidly advancing, and you don't want to sort of be stuck with archaic machines that can't run. The counter to that is exactly what you pointed out. We're still running machines from 10 years ago. We're running them well, and they're still productive for us. So there's both sides. There's of course technical developments that make it easier, faster, cheaper, whatever it may be. But for us, there's still reasons to use the old machines. Like for us, material change out. The SLM 280s are 5, 6 year old platform at this point, but they still are workhorses for us. They still work very well. But the industry is still developing larger machines, more lasers, so more productivity in that sense. And so we're always looking to expand. And so we sort of have this life cycle approach where we're looking at aging out older machines to see if they're still viable or not. But then we're always looking at what's next and what's new and what's available. So for us, we will be, and we already have plans and solidified agreements to transition to large format machines later this year. And so the evolution is inevitable, and that's something to consider for someone just getting into it too, is what do you think that cycle is? Is it 5 years, 7 years, 10 years of that rotation?
But at the same time, don't find yourself with your feet in concrete. You're not going to move because you fear obsolescence so much. So it is a very real possibility. Things will advance over time, but it's not a given that it's going to be tomorrow or next year. And you just made a very big investment in something that's a boat anchor. That
Yeah.
latter portion isn't true.
Oh, agreed. Yeah. And
Okay.
if you've done your homework and you understand the payback cycle for your machine, then you won't be worried about it, because if you've bought a machine and you've already pre-selected a customer, product, whatever it may be, you understand that it's going to be paid off after X number of years. And you're just happy to get the extra longevity out of it if you do. And you've already planned ahead from that. So it's not a surprise. That's a key as well.
Excellent. That was kind of, forward looking. So let me just close with uh, your perspective of where additive will be in the context of traditional machining and stamping and casting operations for the job shop. Is it without a doubt, you must convert now? Is it you've got time, but you got to start planning? Is it no, you got an option. You can choose to be traditional job shop and do no additive and partner with people. Where do you think things are? Well, let me start off with, will additive completely displace traditional processes? And then go to that first part.
Sure. So for me, not in the short term. Machining has gotten incredibly competitive, especially with additive. The technology advancement in machining is also really good, especially 5-axis machining or some more advanced techniques. And so in a lot of cases, machining is still cheaper than additive, but there are parts made from additive that can't be machined. So there is sort of two sides to it. I do think that the best time to get into additive is always yesterday. So you should look into it, even if it's a small portion of your portfolio, to see if it's right for you. It may not be. If you have a successful CNC business, it doesn't mean you automatically buy an additive machine and that'll grow your revenue. So there's a lot of considerations that we've already talked about in this discussion, but I think it's a consideration for sure.
Okay, excellent. With that, I'm going to close it out. We've been talking quite a bit. Mike, I really want to thank you for investing your time today to be our guest, to share your insights and experiences. And I really found it to be a very good conversation. And I believe those watching have quite a few takeaways that they will consider for their additive manufacturing plan. So, Mike, thank you so much.
Appreciate it, Todd. Thank you so much.
And once again, thank you, SLM Solutions, for making this conversation possible. Now, if you heed Mike's advice of getting started yesterday to spur you to action, I highly recommend you take a look at SLM Solutions' portfolio. Or If you're looking to add to your metal additive manufacturing portfolio, do the same. You can get started by visiting www.slm-solutions.com. Last request I have is of you, the audience. If you could be a guest on this program, or you know someone that has the insights and information that would be valuable for other job shops to hear in an additive manufacturing context, we'd really like to hear from you and consider you as one of our future guests. So if you're interested or know someone interested, please drop us an email at andyf@fmanet.org. And with that, I want to thank you for joining us today, and I wish you all the best in your additive manufacturing journey.